Hello everyone. What I want to do in the next few videos is finish up annuities. We're going to look at some kind of special annuity situations that are a little more complicated than what we have talked about before, but as we'll see, these are very practical situations. So the first situation is as follows. Let's say I want an annuity that gives me $10,000 at the end of the first year. Let's say it's a 20-year annuity. And let's say this increases 2% at the end of each year. For example, you might want your annuity to increase to counteract the effects of inflation. Okay, so what's the price of this 20-year annuity at 6% effective annual interest? Or we could also ask, equally relevant and important is, for such an annuity, let's say I take at the end of each year, immediately after I get my $10,000, or immediately after I get my yearly payment, I reinvest at 6%. What would be the accumulated value in this account that earns 6% interest if these annuity payments starting at $10,000 increase by 2% each year? Okay, so so in general, let's say we have n periods. Payments are at the end of each period, and they start at P. And if, let's say, as a percentage, they increase by 100 times R percent per period, where R is some decimal. Okay. So in this case here, R would be 0.02. So the payments starting at 10,000 increased by 100 times 0.02, which is 2% each year. Now let's say the per period interest rate is J. So we have the following timeline here. So the first payment is P that accrues n-1 periods of interest at the per period interest rate J. Okay, so so the annuity increases by R times 100%, where R is a decimal. So the annuity is just going to be for the second period, at the end rather of the second period, P times 1 plus R. Well, that accrues n-2 periods of interest. So it's P times 1 plus R, which is the amount you're getting paid, or the amount you're paying someone, whatever perspective you take. And again, that accrues n-2 periods of interest, so it's 1 plus J to the n-2. This amount increases by 100 times R percent, so you take this amount times 1 plus R, it's P1 plus R squared. That accrues n-3 periods of interest. The 3 got cut off here, but it's an n-3 here. And we just keep playing this game. The second to last payment will have increased n-2 times. So it's P1 plus R n-2, and only accrues 1 period of interest. So it's at times 1 plus J. And the last payment that increased n-1 times is going to not accrue any interest. So that's going to be P1 plus R to the n-1. And if you're wondering about the pattern for increases, well, the pattern's pretty straightforward. This is an exponent 1. So it would be 2 minus 1. This is exponent 2, 3 minus 1. This is exponent n-2, n-1 minus 1. And then finally, this is an exponent n-1, it's n minus 1. Okay, so I don't want to dwell on this too much, but let's write all these terms down. And here it is. We're just starting, we're starting with the first payment P and then just adding all them up. Okay, so we can write this in shorthand notation. So it's going to be the following, and that's easy to check. You should be able to get the pattern here of the powers. So when k equals 0, it's just 1 plus j to the n minus 1, which is right here. K equals 1, it's 1 plus r. 1 plus j to the n minus 1 minus 1, which is n minus 2. K equals 2, 1 plus r squared, 1 plus j to the n minus 3, so on and so forth. The final one, k equals n minus 1, it's 1 plus r to the n minus 1, and there's no 1 plus j. Okay, so how do we get this to fit the geometric series formula? All you do is factor out a 1 plus j to the n minus 1, along with the p that I factored out before. All right, and then you have 1 plus r to the k, 1 plus j to the minus k. Bring the 1 plus j to the minus k downstairs. And use your geometric series formula here. This is kind of, this whole thing here in brackets is my, quote unquote r. So it's always 1 minus r to the highest power here, which is n minus 1 plus 1 over 1 minus r. And here you have it. Well, this is a bit cumbersome. So let's distribute a 1 plus j to the n in the numerator and distribute the 1 plus j to the minus 1 in the denominator. And if you do that, you should check that you'll get this nice, neat formula for the accumulated value of an annuity immediate, where payments start at P and increase by R times 100% each period, where R is some given decimal. Okay. And you can just basically draw the time diagram for present value, or as always, whenever you have anything really, and you know the accumulated value, you can always just times everything by 1 plus j to the minus n, which is literally discounting everything in the annuity, by n periods. I mean, for accumulated value, you're time valuing everything at the end of the annuity. When you multiply by 1 plus j to the minus n, you're basically shifting everything back to the beginning. So either way, you get the following formula for the present value of an annuity immediate, where payments start at P and increase by R times 100% each period. And again, R is given by some prescribed decimal. Okay, 2 quick comments here. It doesn't matter if J is bigger than R or R is bigger than J. Because either the top and the bottom are positive, or the top and the bottom are negative, in which case your whole answer is positive. And also, I'll do the case J equals R in a second. I mean, you really should identify the case J equals R here as basically a derivative and get the formula, but you don't want to do that. I'll do that in a moment. So let's go back and do this problem right here. Okay, what's the present value of this annuity here? Okay, so let's just quickly go and see. Okay, so this is pretty plug and chug. Not a whole lot to this one. P is 10,000. Just to make sure we're all on the same page, I'm going to do this quickly. I mentioned it's a 20-year annuity. I didn't put it on the PowerPoint, but I'll do that after this. And it increases by 2% each year. So R is 0.02. So the present value, which is the annuity price, is 10,000. 1 minus, let's plug and chug, 1 plus R over 1 plus J. It's 6% effective annual interest. So And of course, this is, this is too simple for a quiz or exam, but anyway. So plug this into your calculator. We get 134, 168, and 64 cents. Okay, so let me next do a problem that is something I quite like because it's incredibly realistic, in my opinion. And that's the following. Let's say you are a landlord and you charge rent, and each year you increase rent 3%, starting at $1,000 rent per month, which actually is pretty close to what I actually pay rent for, what I actually pay for in rent, and it's pretty standard around here. But anyway, so right. So let's say once rent is collected, you don't immediately need the money, so you take the rent payments and invest it into a fund earning 2% effective annual interest. How much do you have after 20 years? So it's a very practical problem. You collect rent, and I mean, you don't really, interest is going to change year to year, of course. But as a rough estimate, you might just want to say, well, let's just assume a flat, conservative interest rate of 2% for an investment, which is pretty darn conservative. I mean, you can probably, even now, you can possibly find CDs for more than 2%. Okay, so let's do this problem. So the key to doing this problem is to break the problem up into, kind of find the accumulated value for each year. And then within a separate timeline, so I'm going to draw a timeline for each year, not literally 20 timelines, but one timeline representing an arbitrary year. And then I'm going to draw the timeline for all the years. So what do let me actually get to this if that was a little unclear. Okay, so first of all, first thing is first, to get the accumulated value for each year, I need the monthly interest rate. So we just take 1.02, that's the effective annual interest rate, raise it to the 1/12, that's going to be the growth factor per month. Subtract 1, and you get 0.00165. Okay, right, so real quickly, you don't really have to do this, but make sure we're all on the same page here. And so the pattern is very easy to see. Let's just make a little table of year and monthly rent. So the first year monthly rent is 1,000. Sorry. It is 1,000, but so year 1, 1,000. Okay. Then year 2, well, it's 1030, of course. 1,000 times 1.03. It increases by 3%, so it's 1030. This increases by 3%, so it's going to be, well, it's much better to do it 1,000 times 1.03 squared, and that's 1060.90 cents. Sorry about that, didn't want to do that. Okay, so in general, you can already see the pattern. You're just basically going to take, well, just take the year, subtract 1 from the exponent. So it's 1,000, 1.03 to the n minus 1. So at the very last rent payment after 20 years is going to be 1,001.03 to the 19. Okay, so let me write down the timeline for each year. So in particular, let's just write down the nth year timeline. And if you don't feel like you need to do this, you understand the situation, fine. That's okay. I don't have a problem with that. I'm not sure if I would draw this timeline, but I mean, certainly for quizzes, exams, homework, when in doubt, draw a timeline. Okay, so, right, so, so let's just draw the month, or write down the months all the way to 12. Obviously 12 months in a year, so 0, 1, 2, make sure I can fit this, 11. Okay, so yeah, so this is just a plain vanilla annuity. We figured out what the payment for each month is for the nth year. It's 1,001.03 to the n minus 1. Let's see if I can fit this. As always, challenge of timelines is fitting everything in. That's not too bad. 1,001.03 to the n minus 1. Make this a little bigger. Okay, and the last one for the year, again, think about 11 being December 1st. That's the last rent payment for the year. You're not going to pay this year's rent payment on December 31st or January 1st. That's next year's. So we're not going to include that. 1.03 to the n minus 1. Okay, so this is just simply make this nice and big. It's not going to work. Sorry about that. Give me 1 second. There we go. Give myself plenty of room. Okay, so it's 1,000. 1.03 to the n minus 1 times s double dot. So this is the monthly payment you're getting in. Well, 0.00165. That was what the sorry, 12. It's 12 months. And the interest rate is 0.00165. Okay. Okay, so right. So let's say P be 1,000 s double dot 12.00165. Make that a little bigger. Okay, and let's just quickly get what that is. Might as well. Okay, so clear time value of money. Actually, I have to format this real quick, but that's okay. Just give me 1 second. Sorry about that. Enter. Whoops. Okay, so we have to go in begin mode because we're doing annuity immediates. Sorry, we're doing an annuity due. So clear time value of money. Okay, so right, doesn't matter what order we enter this in. I'll make it a minus. Doesn't really matter. Payment If it's a plus, you'll get a future value of negative 12. And remember, as a percentage, this is 0.165%. Compute future value. And this makes perfect sense. You better get an answer pretty close to 12,000 because you're not earning that much interest and you're getting in, without time valuing anything, you're getting in 12 payments of $1,000. So it better be darn close to 12,000. And it is. Sorry about that. So what was this here? Well, I have it written down here. So it's 12,129 and roughly 48 cents. So this is a bit long, but if you understand, what's going on, you can do this fairly quickly. Okay, so I'm still going to call this P because P is a lot easier to write than this number here in a timeline. So let's write the yearly timeline. So we know exactly what's going on year after year after year. Let's write a timeline for everything, for all 20 years. Okay. So 0, 1, 2, 3, a little better, et cetera, 19, 20. So this is a perfect example to illustrate, I think, how the calculator does make this a lot quicker, but there is there's not one single formula you can just mindlessly plug and chug into your calculator to get the answer. Though you saw how quickly this was using the calculator to get P. Okay, anyway, so it's P, the first, at the end of the first year, that's accumulating all of the first year's rent payments at the end of the first, to the end of the first year. And that's for just the first year. Now let's do the second year. Let's accumulate all of the rent payments and see at the end of the second year what they accumulate to. Well, we just go back here. Right, so everything, basically, this is just 1.03 to the n minus 1 times P. That's exactly what this is. And there's nothing special about year 1, year 2, year 3, etc. We did this for any single year, so for every single year, it's just P times 1.03 to the n minus 1. So n equals 1 is just P, n equals 2, it's, and this is confusion, this is year. So it's 1.03 P, 1.03 squared P, n equals 2, going back here. And then just keep going. When we plug in 19, it's going to be to the power 18. It's actually I have different colors, so I might as well use it. Right, so it's everything here. Can't really. Again, this whole thing multiplied by itself is P, so it's P times, well, n equals 19, 1.03 to the 18, and then finally, at the end of the 20th year, it's 1.03 to the n minus, well, 20 minus 1 is 19. Okay, so plug that all in. Whoops, sorry about that. Ooh, go back to black pen. Yeah, as I said, I really like these problems, so definitely get used to them. So 1.03 to the 19th. Anyway, I mean, so I'm trying to just illustrate that this is exactly a geometrically increasing annuity. It increases by 3% each period and each year, and we start off with P. Okay? And again, the interpretation for, let's say, 20 at the end of the 20th year is that we're looking at the accumulated value of that year's rent payment. Time, everything that, that all these rent payments, time valued, accumulated at the end of the 20th year. It's 1.03 to the 19 times P. Okay, so now we're in a position to just plug and chug. Okay, so right, we're going to use our geometrically increasing annuity formula. So so here we are in years. So this is 0.02 for our formula. R is 0.03. P in our formula is 12,129 and 48 cents. Let's do the whole thing. 48186. Yeah, that's all we need for our formula. So the accumulated value at the end of the 20 years for all these rent payments is P. Now, I don't think there's any way to, just plug and chug into a calculator for this formula. It's really just the time value of money keys. So we'll see other formulas that involve the time value of money keys. This one, it just, there isn't, but it's still a pretty straightforward formula, so it shouldn't be a problem. Okay, so it's, let's go back to the formula real quickly. So yeah, it's 1 plus j to the n minus 1 plus r to the n over j minus r. Okay, so it's 1.02 20th minus 1.03 to the 20th. And again, as I mentioned last time, if you really don't like, so it's 1.02 minus 1.03. If you really don't like doing these kind of calculations on your BA2 plus, I would get the TI30X, the exam P and exam FM allowed calculator that's has a multi-view, so you can see exactly what you're entering, and it's just much less cumbersome for these kind of calculations. And it's only 20 or 30 bucks. I use it to pass exam P. I personally loved it. I mean, it's, as I mentioned, it's literally a TI 8090 fancy calculator, minus the graphing and programmable features, which, good or bad, doesn't matter, because you're not allowed to use calculators with those features on either exam, probably any actuary exam. Anyway, so enough of that. So it's 388, 342, and 15 cents. Okay, so I think this video is about almost hitting half an hour. So I'm going to end here, and in the next video, I will talk about, well, actually, before I end, let's just see what happens when R equals J. And as I mentioned, sorry about that. Sorry, some issues with Zoom. Right. So as I mentioned, really, when r equals j, you can interpret this as a derivative. That should make sense if you're an actuary major. Um, at this level as of an actuary major, that should absolutely make unambiguous sense. Interpreting when j equals r basically as a derivative, or at the very least using L'Hopital's rule. Um, but anyway, we can just actually straightforward get the formula when r equals j. When r equals j, well, let's just go back to where we were. So remember, this is what we so actually, I think I will, yeah, I'll do this in the next, yeah, I'm going to do it in the next video. This is getting a little bit long, so I'll do r equals j in the next video. Okay, right, so long, take care, and until next time, new homework will be coming soon.